Hi, welcome. Hello, Nishant. Hello, Tanisha. Can you guys hear me? Hello, Messi. Are you there? Can you still hear me? Hi, Nishant. Hi, Tanisha.
Yes, yes, yes,
How
we
are you
can hear
doing?
you.
Okay. Okay. Yeah, I can see your income message. All right, so I'm just going to go straight into it. Uh, I'm going to share my screen, and please feel free to ask questions wherever you don't understand. Okay, so today we'll be looking at introduction to OpenAI. We'll basically just be going through the basics we have. Then in the consecutive class that's coming up, we'll see more of how to use OpenAI and their keys. Let me just share my screen. Okay. Please acknowledge that you can see my screen.
Uh,
Going through
yes,
the
we can see
basics
your
we
screen.
have. Then in the consecutive class cool. Coming up, so this is the one of stage B, live coding session, and we want to take a brief look at OpenAI. So we're basically just going to be walking through some slides, after which we'll jump on a notebook and see how it works with some little examples. And we're going to be using an open source that's Hugging Face to look at some example. Okay. So you may be asking what is OpenAI? All we're hearing OpenAI, OpenAI, OpenAI. OpenAI is not just another tech company, right? It's a non-profit research organization that focuses on developing artificial intelligence. We all know about ChatGPT, one of their products. Now, what makes it unique? It's committed to creating AI that benefits all humanity, ensuring the technology is used for good. It was founded in 2016 by well-known figures like Elon Musk and Sam Altman. OpenAI has set high standards for the future of AI. What are their missions and vision? Their mission is straightforward, right? So they ensure that artificial intelligence develops a way that is safe and beneficial. They're dedicated to advancing digital intelligence in a manner that most likely benefits everyone. And they have area of focus. Their research spans several criteria, right? Where they focus on covers a lot of different areas in AI. And we're going to be seeing some example of them. Let me go to it. So you have the natural language processing NLP. So you've heard of NLP. So how did they come in this part of NLP? It's about teaching machines to understand and generate human language, right? Imagine a computer that can converse with you as natural as a human being would. I think we have one. I can't recall the name. It's just audio, right? Once you speak to it, it has a way of speaking back to you. That's it. I think age or thereabout that we have such an AI. You have reinforcement learning too. AI system learns how to make decisions by trying out actions and learning from the results, much like learning to ride a bike. Okay? We also have the computer vision part, which is also one of the area open AI focus on. It involves giving machine the ability to interpret and understand visual information from the world, right? Similar to how human visions would work. The open AI believes in responsible AI development. They advocate for transparency and safety, implementing measures to reduce potential risk associated with AI technologies. Right? Their goal is isn't just to advance the science of artificial intelligence, but to do so in a way that aligns with broad long-term benefits to the society. Hope you guys can still hear me. Please feel free to stop
Yes, we
when
can hear you.
okay, feel free to ask questions at any point in time. Okay, I'll go on to the next slide. This is an overview of OpenAI. We want to continue our journey into the world of OpenAI by focusing on one of their most significant contributions to artificial intelligence. OpenAI isn't just another player in the field of AI. It's a leader, especially known for pushing the boundaries in NLP, right? They say it's a star among other models. We have the GPT-3, started GPT-1, 2, and now we have GPT-4, which is the current series that they are working on. So one of the standard achievements of OpenAI is the development of generative pre-trained transformers. That's the full meaning of GPT. For those of us that are not aware, these models are a big deal in the tech world today. Why? Because they are incredibly powerful and they are trained on vast amounts of text and code. So what are the capabilities of these GPT models? They can generate various forms of creative text, such as poetry, scripts, music, images, right? They can also translate languages, right, from English to French, Spanish to Germany, and the rest. They're also good for answering questions, right? They're also good for answering questions. So beyond GPT, while GPT series might be the flagship, OpenAI's innovation doesn't stop there. They are also exploring other model architectures, right? Tailored for different applications such as robotics, right? They're also developing AIs in that field, in those industry, robotics, right? They develop AI that helps robots interact with the physical world, learning from their experience, much like human would from touching and moving objects. They also have the universal useful intelligence agent. These are AI systems designed to learn and adapt across various environments, aiming to achieve goals in diverse range of settings. Right. So OpenAI work is revolutionary, not just in creating models that can write and translate, but in building intelligent systems that can learn and adapt across different disciplines. So the next slide, we're going to see how to understand the GPT model. So having seen and discussed the broad capabilities, right, the translation, the answering of questions, the creativity of OpenAI, we want to see how it was evolved to the current stage it was. So we're looking at the GPT family tree, right? It started with GPT-1 in 2018, that's the foundation. So GPT-1 was the beginning of it all, launched in 2018. It was finally designed to predict the next word in a sentence. That was how little it started, right? Its ability to understand and generate language was foundational, setting the stage for more advanced models. So think of GPT-1 as the first step toward understanding language works at a machine level, dealing mainly on simple text and basic predictions. That was just how it started back in 2018. Then in 2019, they released the GPT-2, right? Bringing in more improvements over the previous one. So this model was capable of generating text that was not only coherent, but was also rich in context. It could write paragraphs that felt as if a human was writing them, right? That was what GPT-2 was able to do. It was able to also form short stories, the news articles. That was one of the capabilities GPT was able to do. We're still going to see more of it in some slides coming up. We have the GPT-3. The GPT-3 was a game changer. Back in 2020, a true leap was achieved in AI capabilities. This model expanded the horizon of AI generated content, handling everything from answering complex queries with precision to creating different content across various formats. It also had the ability to write its poetry and even simulate conversation, made it seem almost indistinguishable from a human being. Then we have the current one we like the ones that are currently working on GPT-4, which is still under wraps. So the anticipation is very high. It's expected to surpass all previous models, right? So this before aims to tackle more complex tasks, enhance realism in text generation, and provide even more understanding and response. So the evolution from the one to four illustrate not just technological advancement, but a deep understanding of how artificial intelligence can mimic and enhance human cognitive functions. Let's move on to the next slide. Please, if you have any question, feel free to stop me and ask. So let's still look at GPT-1, but I just want to break it down. So what were the key advancements in GPT-1? Its main breakthrough was demonstrating the potential of deep learning, specifically for natural processing language, that's NLP. It was actually a big step showing how machines could start to understand and generate human-like text based on large-scale data that they were trained on. Okay. So the core focus of GPT-1 right back then was language modeling. What does this mean? Essentially, the model was trained to predict the next word in a sentence, like I said previously. This might sound simple, but it's a complex task, trust me. It's complex that it involves understanding context, grammar, and even some elements of common sense. Let's take a practical example. The sun was, let's say, which one is not going to come up with? Okay, let's say the sun was shining brightly. So based on its training on a diverse data set of the GPT-1 might predict the next word to be in or there. I'm just trying to give an example. So this prediction is based on the statistical pattern that it has learned essentially. What was typically follows others is similar context. So the significance it brought was the ability to predict the next word late in for more advanced capabilities in later versions of the series. It was first step towards creating AI that could write poem, compose email, and even generate code. Then why GPT-2 had more advanced feature than GPT-1? Okay, so the key advancement was the excuse me. So it came in 2019, like I said, and this part of it, it had the ability to understand and generate human language. Okay, and the key advancement was it enhanced the ability to produce text that was not only coherent but also impressively realistic. This model was a significant step up from its predecessor, demonstrating a deeper understanding of language knowledge. And it focused on two main areas, enhancing the quality of text generation and improving translation capabilities. We have another example. So imagine prompting GPT to write a news article. The AI would generate a well-structured piece with a clear introduction, body, and conclusion. That was what GPT-2 was able to do, right, compared to GPT-1. The text would sound natural with sentences flowing logically from one to the next, much more like something a skilled human writer would produce compared to the simpler output of GPT-1. So this advancement was not just a technical achievement, it had practical implications for applications like content creation, where ability to generate readable, engaging text can be invaluable. Okay. So it also demonstrated potential for use in applications requiring translation between languages. So people started, making use of it. Maybe if you had an app that you want to translate from one language to another, and maybe you have users in different countries, you can actually integrate GPT, right? So it makes communication more accessible across language barriers. So GPT was actually a groundbreaking model that showed the world how far AI can go in understanding and creating human-like text, right? Its development represented a very crucial step towards more sophisticated AI systems, which could eventually assist in a variety of both professional and creative tasks. Hello, hope I'm still audible. Hello, hello, can anyone hear me? I
Yes, you
can
are still
see it.
audible.
All right, so
Yeah.
pardon all the hotel scale stuff. We are soon going to do some practical aspects of it. Right, this is just the introduction, and we still have 3 more classes to go. So as we progress, we'll go into more advanced code, and I think in the third class we'll get to use the OpenAI key, see how it works and how you can make use of its API. Right, so I'll just jump on the next slide, 53. Right, this was introduced back in 2020. So the key advancement, it really dramatically pushed the boundaries of what AI can achieve in generating realistic and creative text. Right, its capabilities vast. Sorry, I noticed someone muted my mic. Okay, so yeah, its capabilities vastly exceeded those of its predecessor, making it one of the most powerful language models ever created. So the focus area, unlike earlier models which primarily focused on text generation and translation, right, the GPT-3 expands into broader range of applications. It had the ability of writing diverse forms of creative content, responding informatively to complex questions, and even creating text in various formats tailored to specific context, right? So a practical example is in creative writing. If asked to write a poem about a cat, the tree can produce a lyrical piece, right, complete with rhyme and meter, much like a seasoned poet. That was one of its abilities. It also had the informational response. Suppose you are asked to about the history of cat, the 53 back, right, can create a very detailed and comprehensive summary, drawing from a vast database of knowledge, much like a knowledgeable historian. So the development of the picture showcases the potential of AI to not only mimic human-like text generation, but also to offer practical solutions for a wide array of tasks across different domains. Okay. So with GPT, we are witnessing an era where AI influences content creation, education, and even customer services. Its ability to understand and generate human-like text has opened a new possibilities for AI interactions. Okay? If I may throw a question out there, can someone on his or her own just say something about how GPT could transform educational tools? Anyone want to try? What do you have in mind? How can GPT transform educational tools? What do you think can help? Anyone want to say something? How can GPT assist in creating learning materials or providing personalized learning experience? I'd love for someone to just say something. I can see Yusuf. Yusuf, do you want to say something? How GPT can help in the education industry? Okay. Ridwan, do you want to make an attempt? How GPT, based on what I've said or what you've learned, how it can help in the educational industry?
I'm sorry. I will talk later. I'm currently not stable now.
Okay.
Do you hear me?
Yeah, I can hear you. All right, that's fine.
Sorry.
Jamal, do you want to try? How can GPT help in the educational industry? How can it assist in creating, learning materials and providing analytic experience? Tanisha, are you there? Okay, Jamal, your mic is there.
One way I can think of is if you have like maybe professors or students or academic people working in academics that are trying to work with a lot of documents, for a specific purpose. They can use the GPT to kind of summarize to get an idea before going into the particular document. So that's one way in the educational sector.
Okay, thank you for that, Jamal. Tanisha, do you want to say something? Ridwan, are you there? Was it Ridwan that said, okay, I think Ridwan said he's not in a comfortable place. Nishan, are you there? Okay, we don't want to spend much time, we're almost 30 minutes in. So you want to just conclude on this? Right, so based on what we've said so far, we've seen the evolution of the GPT from GPT-1 back in 2018, which was the initial steps in language modeling, to GPT-2, where the enhancements in generating more coherent text, and finally to GPT-3, right, which was like, we say it was a quantum leap in creative and informational capabilities. Now, each version of the GPT-3 was built upon the learning and advancement of its predecessor. So it's like we said, reinforcement learning. They learn from predecessor. So it's built on top of the other one, right? Demonstrating OpenAI's commitment to pushing the boundaries of AI technology. These progressions highlight not just technological advancements, but also a deepening understanding of how AI can interact with and process human language in a sophisticated ways. Okay, so at this point, I'm just going to jump on the notebook so that we can take a look at some code of how this stuff work practically. And this is stage B. So I'm very sure during your stage A, you must have got familiar with some concepts like Hugging Face and the rest. Please confirm that you can see my Google Colab notebook. Oh, okay.
Yeah, we can
Can you
see.
guys see? All right. Cool. So I have a notebook here, which is just going to with some codes already written. So practically what we are going to be doing, we are just going to be copying each of them and running it, see how it works. Okay. So I'm using, or we are using right now in this class, an open source um model that's from Hugging Face. That's where we are picking it up from, right? And I think in class 3 we are going to be using that's I would say we are going to be using it for now, but if it's possible, we are going to be using the Open AI key as of class 3. But right now we're using the open face open source model. So this one is easily accessible by everyone so that you don't have any restriction of open AI keys. So we're using Hugging Face transformers to look at some examples, and we are using the two. And I think here we are using the two medium. So this one is more advanced than the other one. We have the first example that demonstrates basic usage of original GPT model for generating text. Okay, so I'm just going to check this off, then walk us through the code and then run it. Okay, so we are taking from transformers with two models, a model and a tokenizer. So like I said in stage A, you must have gotten familiar with most of this tokenizer. It literally converts, models understands numbers, right? So tokenizer convert those text into vectors that the model can easily understand. So that's what is happening here. We are loading a tokenizer and we are using a pre-trained model, right? We all know that it's trained on billions of data, and we are talking about Spark computers here, right? So you wouldn't want to say you want to start training a model from scratch on your own, right? Unless you are
Sorry, I'm sorry for interjecting. I have a question.
okay.
I'm wondering, is it if tokenizer is the one converting to vector, like digit number, what about embedding?
I think they work alike.
Do you get my question?
Yeah, yeah, I got your questions. I got your question. So yes, the two are just likely the same thing. When you say embedding, you are literally converting the text into vectors to embed into the models. And that's what this tokenizer is doing. So tokenizer embedding two similar words. Do you understand?
Yeah, I got you. I got you.
Okay. Someone dropped a message for me. Okay, I think the network can be shared across. All right. So yeah, back to I've seen the message on the in chat. I think um yeah, Tanisha, the notebook will likely be shared across to you guys right through the admin. Okay, so someone asked about the tokenizer and embedding. So like I said, like there are two similar things. Here's what tokenizer does, right? Just a component that break down the text into smaller units. The person that asked the question is can the person still hear me?
Yes, I can. I can. I can.
Okay, so tokenizer, what it does, right? It breaks down the text into smaller units, right? Which can be word, subword, or character. And it actually converts the raw text into a structured format that the machine model understands. Now, what embedding does is to convert tokens into a form that has meaning. You know, when you say breakdown, when they say the dog, this is a dog, tokenizer is literally just going to break it let's say into smaller. Now, what the embedding does, right, is used to convert that token into a form that make meaning or has a working relationship or properties while they are in the vector space. I don't know if you got that.
Yeah, that's clear. That's very clear.
Okay, right. So here we have loading our tokenizer, our model. Then here is where we pass in the text, the quick brown sub. So we are, tokenizing it, encoding it, and returning it as a tensor. And then we are passing it into the model to generate using the input IDs, that's the vectors that are coming from here. And we want a maximum length of character 50. Then here is where we are printing the output. Okay. So if I run this, so it's going to take some time. Sorry, connecting, just give it a second. All right, so yeah, these models are always large. All right, so here is the result. Please ignore all these warnings. So it generated to output. The quick brown fox are a great way to get a little bit of a kick out of your dog. And another one down here. So because we set the maximum length to 50, that's why it just had to stop here. And even we did not set it, it would have continued creating as many as it wants. Okay. So This is just a very simple or short code where you can write that does text generation using the GPT-2. So using the open source, like I said, you just load in your GPT-2, bring in your model and the tokenizer, because tokenizer is actually what you're going to use to convert the text into what the model can understand. Then you run it, it's just going to go ahead, pick up what you gave it and start generating a text. Let's go to the other example. Still on that text generation, but this time around we are using a different model. I'll go ahead and run that. So if you change the model, all right, this is where you change it. It's just going to go ahead to pick up that particular model from the open source. Or the warning we had initially, it's if you are not connected to Hugging Face. Hugging Face, you can log in into the interface. So that's why it's bringing up all those warning. And so here we set a maximum length of 100. So you can see that it has to stop on reaching the 100 character. But this is it's generating text or generating some content based on what you pass in. Okay. So it picks up the input context, it converts it, return it as, sensors, which was now then passed into the model and start generating the text, the maximum length of 100. And here's where we are decoding that output, those vectors into a readable code. And here's what the result looks like. So we have two complete results, and yeah, you can see it was about just repeating the same thing all over again. So most likely these are like some of the limitations we have, the repetition, and maybe you may be wanting a different context, right? I think this is where the prompt engineering comes into play. That should be our next class, where you are able to specify the kind of results you want it to bring out for you. But right now, had it been we did not set this maximum length, it's probably just going to go on and generating the same thing all over again. Do we understand so far? Any question? Does anyone have any questions so far? Ridwan, Tanisha, Ozadima, any question for me so far?
You've answered my question recently.
Oh, okay. All right, cool. We have, I think we should just jump the text. It's mostly text generation. But yeah, let's see what the trying to predict for us. What is happening? Google Colab is fond of bouncing people out. Okay. Please just give me a sec. Google Colab is asking me if I'm a human being or not. Okay, I've sorted that out. Here's another thing that is possible. We have the prompts, the encoding, the generating, and the decoding of it. These are just minor steps you can follow. I think after that, we'll probably just jump to where we introduce some parameters. Let me just run that. Okay, sorry, I think I copied the same thing. Sorry about that. It's not. Okay, so here is the result for this. Yeah, maximum length of 50. It's literally repeating the same thing all over again. Okay, so enough with the code generation. Actually, the difference in most of this code are the versions of the GPP I'm using. Here is another one that is still on Hugging Face. This one is GPT new, which is as close to GPT-3 like. Right? It's just similar to GPT. It does what GPT-3 does in a way, and this is how you can make use of it for text generation. And we've seen what text generation looks like. Here's another GPT, another module. Okay, you can still use it for text generation. Let me run the chain. Then after that, we'll just jump in and see how we can introduce some parameters to have more control over how it operates. Oh, it's loud. Last time I run it took some time. Okay, because of time, I'm likely going to stop it. Okay. Right, so let's just allow it to run. So while it's running, we have some parameters that we've seen some of them, like the maximum length. I kept talking about the maximum length. We have some other parameters that we can introduce to those code to have more control over it, right? So if you want to limit, like you saw somewhere repeating itself, if you want to limit the response of the model when generating text using Hugging Face transformer, you can use several parameters in the generate method. This generates that we've been using. So far, we've been using max length and the input IDs. So we can actually also introduce some other parameters, right? So some of them is max length. This one's already set to the length of the sequence to be in its value, right? It's set it to 100, you have 100 characters. We have the num return sequences. I think we use that one somewhere. Yeah. So what does it do? It specifies the number of different sequences to generate from the same prompt. Right? Setting this to one can ensure that only one response is generated. Only one response is generated. So you see, it's having the same response, though it's what we saw in the previous one, but we're having it duplicated several times. We also have this parameter, no repeat n-gram size, prevents the model from repeating the same n-grams where n can be defined by you, and ensures more diverse and less repetitive text generation. We have early stopping, we have temperature. Early stopping, if set to be true, generation will stop as soon as at least one sequence reaches the end of string token, end of sentence, sorry, token, which is beneficial for not generating beyond logical completion. We have the temperature, which controls the randomness. You must have also seen this in your stage A by scaling the logic before applying the softmax. Lower values make the model more confident, but less more deterministic, while higher values offer more diversity but can also produce more unexpected results. So you have the ability to control that. You have the top pay, which limits the number of highest probability vocabulary. Consider for it the promotive focus on relevant text generation. We have top P, which implements nuclear sampling, where the parameter is a probability threshold that controls the size of the token set, which the next token is sampled. So these are some of the parameters that you can actually introduce to your model to have more control over it. And you can also do more research to understand the data. So here is another example, right? Another text generation, but you can see that here are all the parameters that we talked about, and this is just different settings for them. So if I go ahead, to run this, just give me a sec. Let me see that the person has finished running. Okay, this one is still running. Right, so we're just gonna wait for this. I'll probably have to stop it. But yeah, while it's still running, we are going to run this to see how it have control over the stuff it does. So for the settings I have here, right, for the options we have here, this is going to limit it to 50 tokens, generate only one sequence, prevent the model from repeating any two word long phrases, stops generation when the model reaches the end of sentence mark of generated sequence, balance the randomness at 0.7, restrict the model choice to the top 50, and ensures that the cumulative of the chosen set of potential next word counts for 95% the total probability. So this one is more like statistics if you can comprehend what it's saying. So it's like the next text that it wants it in. You know, they say it generate sorry, it tries to predict the next text. So in the next text, since it's an AI, it wouldn't know if it is in or they or he that will come next. But out of those several options, each of them have probability. So what this is going to do is, out of those words I just mentioned, those options, the one that has the highest probability is what is going to use to, fix in as the next word. So that's what this lesson is trying to talk about. So when you are making use of this stuff, we have some considerations that you should take into place, right? So adjusting this parameter can significantly affect the quality and relevance of generated text. So it's often beneficial to experiment with different values to see how they impact the model outputs, right? So you can experiment with the temperature. Lower values like 0.5 can make text more concise and to the point, whereas higher value can make it more creative but potentially less coherent. Top K, top P can reduce the randomness and make the text more focused on common phrases and ideas. Then you have the max length for length control. Let's see if that our code has finished running. Well, it's taking a longer time. So let me just stop this because of time. Mhm. Oh, okay. Doesn't want to stop. Okay, while we are waiting for it, does anyone have any question he or she wants to ask? We just want
Yeah,
to test run.
there are questions. There are questions in the chat.
Sorry, I have not been looking at that. But let me see. If someone like into what tough P and tough can temperature control. Okay, so let me go back to where it was explained. Temperature controls the randomness of the predictions by scaling the logic before applying softmax. So lower value softmax is just like a stage in a transformer, right? For what's it called? Measuring the output. Now lower values closer to zero makes the model. Again, listen, lower values, the closer it is to zero, it makes the model more confident. But it being confident now, it does not have okay, can stop running. It's being confident but less varied, right? It's more determined. It doesn't just how would I put it, it's more specific. It doesn't go beyond what you've given to it, something like that. While higher values closer to one offer more diversity. So it has a way of maybe going beyond what you've given to it, maybe looking for other context to add to it. But it most times produce unexpected results. Stop here. This limits the number of highest probability vocabulary we can consider for each case. These two work alike. Say the next word, we don't know what the next word could be. I'm trying to write the text. Oh, my system is sounding okay. So it's just like it's trying to predict something. In the next step, it's about to predict. We have different options like it, in, the, if, and why, something like this, right? So what's the top K and top P because they work in hand, like most people can confuse them for one another. This one limits the number of highest probability vocabulary tokens considered for each test, promoting focus and relevant text generation. So this word has, they are all vectors, so they have probability of it being the next item. So what the top K does is to limit how many options this comes out. It limits the options that comes out. Then the top K implements nuclear sampling, where the parameter is the probability threshold to control the size of token state, which the next token is sampled. I think we explained more about that. So look at 50 restrict the model's choice to the top 50 most likely next word. So this is going to limit these different options to 50. While if we set it to 0.95, this ensures that the probability for each of these words, the one that accounts for 95%, are used. So I don't know if I've answered your question, Tanisha. Sorry, who's the Dimma? Please just let me know if I've answered your question on the. Okay, okay, yeah, you're welcome. So we're actually out of time. Let me run this. So this shouldn't take time because the model is small. Let's see what it's going to generate for us. Okay. See, the result is very short and just straight up. So look at the generated text. The impact of AI is clear. The AI is a tool that can be used to help people to make better decisions. It's also a way to improve the quality of life of people. The AI has been used in many different, because of the maximum length. I think that's why it's of the maximum length of 50. But then, because of all these parameters, we said we're able to have more control over the output we have. Even we have another one here. This was before we close. This was one of the exercises we did above. So if we run this to then copy it out. I have it here already. So when I run this code out here, this is what the result looks like. So you see that the result is different from, if you know that this code we ran, this one we ran, sorry, is one of the example. Let me see if we run the example so that we can compare. I don't think we did. Yeah, this is it. This one that has technology advanced, the capability of creating AI. Let's say, okay, we did not run it. You know what? Let's just experiment on that. Let's run it. Then once we run it, we'll now then let me break it down here so that we can easily compare it. Yes, let me run it here. Then we'll compare the output. So this one is where the parameters are not much. It's just the maximum length and num return sequence. Then we'll compare it to when we had more, control. Hold on. I think I'm having the same thing up there. Excuse me. Sorry. We do not run the turn. Let me run it. Okay, so while it's running, if you have any question, please um feel free to ask. We are almost rounding up.
Please ask
Uh,
question in the chat.
okay, let me check. Oh, I have a quick class contains fresh water for the surface control. So they have a good yeah, okay. So, actually, to use OpenAI, like the API, you need to have a credit. So I don't know if it's tough for me to say, but you are expected to have a credit in order for you to be able to use the API from OpenAI. You are expected to have a credit. So if you can't get the credits, I think there are two ways in it, if I'm not mistaken. Yeah, one was through OpenAI, while the other one was through Mistral LB, which was another open source database. So if maybe you're having courses, maybe you want to option for the other one, and record that there are two samples. Okay. So please just maybe you just need to reach out to an admin in Slack channel to respond to that. Okay, so
Okay,
look
thank
at
you.
the output. It has it's different. Guys, because of time, I would love to take questions now so that I can just wrap up. Any question for me? All right, so my time is already off. In the absence of no question, I'm going to call it. We'll end the class. So we'll see on Monday. Yeah, our next class is on Monday, I think by 4. So in that class, we're going to be seeing the introduction to prompt engineering, how we can understand more about prompts and see how we can make use of it. All right, so yeah. Bye everyone.